What's up, guys? Today we're going to look at box plots, which look like this, and it's a graphical representation of summary statistics. It's how we can summarize quantitative data. So it looks like this. We should see some familiar things like minimum and quartiles and medians, and that's what it actually is, an IQR on here. So a box plot is just a graphical representation of the 5-number summary. So in the middle box part, that indicates the IQR, and then the whiskers are extending from that Q1 and Q3 to the minimum and maximum. So if this was my 5-number summary at the top, this is how the box would look. I'm just going to create lines, like you make a number line, and I'm going to put vertical lines on each one of these 5-number summary values, like so. So Q1 was a 1, and Q0 was a 1. My Q1 value was at 4. My median was 6. My Q3 was 9. And my max was 12. And then the box plot just extends whiskers from those Q1s and Q3s to the minimum max. And then you put a box around the middle, like that. And then 25% of our data, of the data values would, approximately 25% would fall into each one of these little groups. So if we were to look at our doing a box plot, which you should, this is what I would have you do in class. I would have you make a number line. This is just the boys' 5-number summary, and you can scale this however you want. I'm going to start right here at 60 and go up by 5. So 1, 2, 3, 60, 61, 2, 3, 4, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. 76, 77, 78, 79, 80. Okay. So now looking at my 5-number summary, I just want something to fit kind of in this range, so I don't have to start at 0 and go all the way up. My Q0, my minimum is 61. My Q1 is 68. My median is 70. And 72, and then this is 78. And we should notice this is fairly symmetric, and it should be, because this is a normal distribution. So anyways, we'll talk more about that next time. But this would be a box plot of the boys. The girls would look the same with just different numbers. Okay, let's look at this one real quick. If you go into your practice page on your Google spreadsheet and type in the following numbers, you should be able to get these for your 5-number summary. And then when we plot those on here, I don't have the, I know that there's an outlier on here, and it's this 53, but I don't know what the threshold was off the top of my head because I don't have my sheet with me as I'm recording this video. But we're basically going to extend the line to the threshold. So I'm going to say that when we did the calculations over here for the outliers, I don't know off the top of my head, but let's just say it's 60. Okay, I'm just going to say anything less than 60 is an outlier. So this is how this would work. Because this is an outlier, and assuming my threshold was 60, I'm going to draw a line at 60, go up to 80, then 87, then 93, and then 98. And so my graph would look something like this, my box plot. And then I would put a point, like a dot, right at the outlier. Like I said, I don't know if 60 is a mark or not, but that's how that would look. And I have an example on the next page. So we should have got that 53 as being an outlier. So we're going to look at just basically kind of interpreting the results of a box plot. This is a study that was done about effects of a professor's reputation on students. And we were told that a sample of university students was randomly split into 2 different groups and then prepped by researchers before observing a professor's lecture. The first group was told that the professor was well-liked and interesting, and the second group was told that the professor was strict. After hearing the reputation, both groups of students attended the same 20-minute lecture and then rated this professor's performance. The box plot shows the results of the survey with rating 1 denoting the first group's results. Your one that was told it was well liked. So based on the box plot, how might we describe the results of the study? Well, we can compare those medians, right? The median of group A, or rating 1, it was told he was well liked, is higher than that of group 2. Also, the range, the IQR, is higher as well. We can see that the maximum for the rating 1, somebody gave them a 4.0, and so we can see lots of things. We can see how the box of the second group is a lot tighter and also less. So those are things that pay into this. So we may look at this and come to the conclusion that students do seem to be influenced by reputation. Some information that we might want to consider before trusting these results completely, because we have talked about like rate my professor before, is did the students know the professor? That's a valid point. I mean, I can't remember how many people were in this. Did it say? Hold on. No, it just said it was split into 2 groups. Okay, so I don't know how many people, but I mean, if you had 10 people for each group, and 2 or 3 of them knew this professor already, that could influence for sure. So just some things to kind of consider before you rely solely on this. But that's what statistics is. It's like looking at the data, looking at what could have been done different, or what information do we want to know further before relying on something. Were these 2 groups allowed to interact either between each other or within their group? And then also we'll talk more about how the sampling collections and stuff like that next unit, I believe, or maybe the one after that. But how is the sample collected? So that's just a little interpretation of box plots, and then you guys have the rest of the class period to finish your Delta Math. Good luck.